Hello everybody. So for today's session, we are going to be going over simultaneous equations. So simultaneous equations is just an application within functions when we have an intersection somewhere within the variables. Okay, but that is functions and we are not going to be going into that detail. We'll go over that in the functions section. But for now, let's learn how to actually solve for x and y, because that is essentially the question in this case over here. So, x plus 2y is equal to 1, and x squared plus 4y squared is equal to 41. So these are both functions, and we want to solve for x and y for both of these functions. These are this will basically be some type of I wouldn't say it's a circle because it's not a perfect circle, but this one is a straight line equation if you were to write it in terms of y. But let's not get into that. In this case, we want to find a way to work with one equation, which we call the first equation, equation 1, and we'll call the second equation, equation 2. And then from here, we need to find a way to eliminate either one of these variables so that we are able to solve for x and y afterwards, or y and then x afterwards. It doesn't matter what order it is, as long as it's easy enough for you to do. Alright, so what are we going to do? What is the easiest approach for this one? For number 1, I would recommend either letting x be the subject of the formula, meaning in the form of x equals dot dot dot, or you would go in the form of y is equal to, and then something else where y is the subject of the formula. Which one is easier? Well, clearly because x is just on its own, it's easier to do that. So therefore, what we'll say is that x plus 2y equals 1 will actually be written as, let me write underneath each other, x is equal to, we just take the 2y over, or we minus both sides by 2y, such that we have 1 minus 2y. Okay. And there we go. Now we have our third equation, where x is equal to something. And then what do we notice here? We have x and we have y in this equation as well. But if we plug in x equals 1 minus 2y over here, then therefore we're only going to have y in the equation. Wouldn't that be perfect? So what are we going to say to the marker? We are going to tell the marker that I am going to sub 3, equation 3, into the equation of 2. Okay? So that is what I'm going to do for the marker, and then I'm going to do my solution. Usually I just underline these things, but you don't have to. Such that what are we going to have? X squared plus 4y squared is equal to 41. We're just going to plug in x in there. So therefore it's going to be 1 minus 2y squared is equal, sorry, not equal to, plus 4y squared. So plus 4y squared is equal to 41. Okay, do you notice all we did was just replace x with 1 minus 2y, and therefore we only have y in the equation. Now we need to solve for y. And how are we going to do that? Clearly we have a bracket squared. And no, you are not allowed to take the square into each term because it is separated by a subtraction sign. Only if it's separated by a division or multiplication can you take that exponent in like that. But now we have to expand it such that we have something squared, which is 1 minus 2y multiplied by 1 minus 2y. So the bracket is just multiplying itself twice, because that's what the square means. Plus 4y squared is equal to 41. And then therefore, in this case over here, we use FOIL method for this bracket. So it's the first, which is 1 times 1, which is 1. Then the outer, which is 1 times negative 2, which is negative 2y. Negative 2y times 1, which is negative 2y. And then therefore, the last, which is negative 2y times negative 2y, which is positive 4y squared, plus 4y squared is equal to 41. We can simplify and notice that we only have one constant on the left hand side, but we do have minus 2y, which is essentially just going to be minus 4y. And then plus 4y squared plus 4y squared, they're both the same, so we're just going to say plus 8y squared. Notice that the coefficients are the only thing that's really adding, and not the variables. And this is equal to 41. Okay. And then from here, we need to solve for y. So we notice that we have a highest degree of 2. So it's going to be a quadratic equation. And because because it's a positive over here on this side, we're going to take the 41 over. So therefore, what we're left with, I'm going to regroup it as well. 8y squared minus 4y. And then we take the 41 over, that's going to be minus 41. So minus 41 plus 1 is just going to be equal to minus 40 is equal to 0. And then notice that what we are able to do from here, we can take out a common factor of 4, because clearly the highest common factor that we have is indeed 4. And then therefore, when we take out 4 as a common factor, we're going to be left with what? 2y squared, because clearly 8 is the same as 4 times 2, and we're just left with 2 as the outlier. So therefore, it's going to be 2y squared minus y on its own, and then minus, when we take out 4, it's the same, 40, it's going to be 4 times 10. We take out 4 as a common factor, we left with 10. So it's going to be equal to 0. And then we divide both sides by 4, so that we are left with 2y squared minus y minus 10 equals to 0. Now from here, clearly what we have is going to be, we have a coefficient, which we don't really like to have over there, but in this case we're going to use the grouping method. So we are going to write down over here 1 and 2 gives, so the left hand side we have 1 and 2, or we can write it as 2 and 1. And then on the other side, where we are working with the factors of 10, we can have 1 and 10, and we can also have 2 and 5. And then from here, we can just take the pairs for each side. So from the left hand side, we're going to take the pair 1 and 2, and we're going to compare it to 1 and 10. So we're going to multiply across over here for this one over here. So 1 times 10, which is just going to give us 10. And then we're going to multiply across here with the 2 and the 1, and then we're going to have 2. Do these values, when you add or minus them, give you 1? It does not. So we can't use that combination. So we're going to use 1 and 2 and 2 and 5 now. And if this one doesn't work, we'll move to 2 and 1 and 1 and 10 and whatnot until we find that combination. So now we're going to use 1 and 2 and 2 and 5. Multiply this across, which is just going to be 1 times 5, which is 5. And then we can also multiply the 2 across, which is going to give us 2 times 2, which is 4. Now, if we have 5 and 4, does it give us 1? Yes. If we minus this, even if we have it the other way around, we can get negative 1 from this whole thing, but that's not what we're really looking at. If we minus these together, we'll get 1. So therefore, the pairs 1 and 2 and 5 will work, where within the bracket, this implies to us that we're going to have our brackets, okay, which is equal to 0. But the first one here, so the top ones, let's do that bracket first. So it's going to be 1 and 2. So 1 on the left hand side and 2 on the right hand side. So it's 1, y, and then we're going to have 2. And then the bottom is going to be 2y, and then it's going to be 5 on the right hand side for here. And then in order to get our sign, we need to figure out how to get negative 1y. So therefore, what happens if we put a, how are we going to get negative 1y? Well, notice that we are going to be multiplying this 1y with the further one here, and the 2y with the 2. And then notice that if we say 5 multiplied by y, we're going to have what? 5y. And we say 2 multiplied by 2y, we are going to have 4y. And in order to get negative y, we need to say 4y minus 5y. Does that make sense? Because 4 is smaller than 5. And if we take 4 first, then we're going to get a negative value. So therefore, we need to take positive 4 minus 5y. So we put the minus by the 5 and the positive by here, by the 2, because that is what we produced. So therefore, we're going to have y plus 2 multiplied by 2y minus 5. Sorry about that. And then from here, we let the brackets be equal to 0. So y plus 2 equals to 0. Or we can have 2y minus 5 equals to 0. And then from here, y is just equal to negative 2. Or 2y equals to 5, such that if we divide both sides by 2, we have y is equal to 5 over 2. Or we have y equals to negative 2. Okay, and there's our values of y. Now, in order to get our final answer, remember, our final answer says find the value of, solve for y, and then also solve for x at the same time. So how are we going to get x? Well, we can just sub in what we have for y in equation 3, and then we'll get our x value, right? So therefore, that is what we're going to do. So we're just going to sub back, right? So we can tell the people that's going to be marking. We're going to sub y values into 3, because that's our equation, right? So we're going to sub our y values back into 3. And then from there, we will have x is equal to what? It is 1 minus 2y for each of them. So 1 minus 2y. So let's plug in negative 2. Okay. And then I also want to check with the other one. 1 minus 2 into 5 over 2. Okay. So from here, if we evaluate, it's going to be 1 minus 2 multiplied by negative 2 is just negative 4, but negative 4 times negative is going to be positive 4, so it's going to be 5. Okay, so that's our x value. And then from here, 1 minus 2 multiplied by these, we notice the 2's will cancel, we're left with minus 5, so it's minus 4. So what do we notice? When y is equal to negative 2, then therefore x is going to be equal to 5. And when y is equal to 5 over 2, then x is equal to negative 4. So in function values, so there's two ways you can say it. So you can therefore say x equals to 5 and y equals to negative 2. So that's basically when they work hand in hand together. And you can also say x equals to negative 4 and y equals to 5 over 2. But when you're working with functions, you would write it in coordinate form. So when x is going to be 5, then the y coordinate would be negative 2, the output. Then when the input of, we have negative 4, when that is the input, then the output would be 5 over 2. That is essentially all we just did here in this case. Okay. And this is obviously in the form of xy coordinates and xy coordinates. So when you get to functions, at least you know when you're dealing with simultaneous equations, this is how you get your coordinates at certain points using simultaneous equations.